about definite and indefinite quadratics. Okay, what does that mean? We're going to look at different cases. So let's look at the first case where the parabola crosses the x-axis. So the parabola concaves up and it has two x-intercepts. So if it's concave up, what's the value of A? A will be positive. And what's the value of discriminant if it crosses the x-axis twice? It means it has two roots, therefore discriminant will be greater than 0. Okay, cool. Write it down. See if you can work out the next one. Look at the graph, you can figure out these informations. So the parabola concaves up again. That means A is positive. How many x-intercept does this have? 1. So Lisa, what's the value of discriminant? It has 1 x-intercept. 0. Very good. All right, next one. We look at the parabola where it is concave up again. A is positive once again. How many x-intercept does this have? 0 x-intercept. Therefore, discriminant will be less than 0. Okay, good. All right, can you fill out the other two? They're the same thing. Have a try. Okay, very good. Okay, right, let's go through the other one. Let's ask Jessica, case 4. So the parabola concaves down. How many x-intercept does it have? 2. What's the value of A? Negative. It's concave down, and discriminant will be, what's the value of discriminant? Greater than 0. Very good. Okay. All right. Fill out the rest. All right. I'm going to ask Jack. Next one. What would you write? Yeah, 5. Yep. Very nice. Very good. Okay. And then I'll ask one more. Maybe Lisa again. Sorry to ask you again. Okay. Can you tell me? So the parabola concaves down. How many x-intercept? 0. A is. And discriminant? Very good. Okay, cool. Okay, done. So we'll fill this in, and we're going to say something about these parabolas. They have special names attached to them. Okay. So in particular, for case 3, all the y values are positive. So can you see, in case 3, all the y values are positive. When all the y values are positive, we say the parabola is positive definite. Okay, that's what positive definite means the parabola is completely above the x-axis. So write down positive definite. Oops. And of course, if the parabola is completely below the x-axis, which is case 6, all the y values are negative, we say the parabola is negative definite. Negative definite. If it's neither case 3 or case 6, we say the parabola is indefinite. Okay, so note the wording. Now, you will see that in both definite cases, whether it's negative definite or positive definite, they have no x-intercept, which means that its discriminant in both cases are negative. Let's write it down. So we're going to say discriminant is negative. When the discriminants are negative, it's going to be either positive definite or negative definite. Whether it's positive definite or negative definite depends on the value of A. So if it's concave up, it will be positive definite. If it's concave down, it's negative definite. So it must have two conditions. So make sure you highlight them. All right, two conditions for the definite. Any questions? Right, pretty simple. Let's move on. So we're going to use these ideas to check whether they are positive definite, negative definite, or indefinite. Let's do that. Let's look at the first question. Is it positive definite or negative definite or neither? Positive definite. So write positive definite. Well done. Good. Now the next one is neither positive definite or negative definite because it's sometimes positive, sometimes negative. The word we say is indefinite. Now, even though it's concave down, it's indefinite because it can be positive or negative y values. And the last one, we're going to ask, Joshua. Okay, last one, what do you say? Very good, excellent. Negative definite. Now we'll know how it looks like. Let's do some questions, which you will get in the homework. Let's go to the next page. Thank you. All right, next page. So, draw a possible graph of the parabola given the following. Hence, deduce whether the function are indefinite, positive definite, or negative definite. Very good question. Let's look at it. A less than 0, what does it tell you? It is concave down. What does this tell you? It means that it crosses x-axis twice. So can you picture what it looks like now? It will look like this. So what do we call that? Indefinite. Very good. Try the next one. See if you can work out. Okay, now next one. Okay, let's see. So it's concave up. It doesn't cross the x-axis. Does not cross x-axis. So it will look like this. So we say this is positive definite. Now we know how to identify them. Let's do some harder questions. Okay, question 15. All right, this one involves some algebra. Let's do that. Determine whether the following functions are indefinite, positive definite, negative definite. You can do that without drawing the graph. Let's see how that works. What's the value of A? 1, it's positive. So we'll know it's concave up, isn't it? Smiley face. Discriminant is b squared minus 4ac. So we're going to square the negative 5 minus 4ac. Now what would that be? What's the value? I would like to have the value before we say positive. 25 minus 8 is 17. So it's positive, isn't it? So what could we conclude? If the discriminant is positive, we say it's going to have 2 roots or 2 x-intercepts. So the graph will look like this, right? So we say it is indefinite. So every time the discriminant is positive, we say it's indefinite. How about the next one? Let's have a try. Have a try before we go through. Have a try. It's very easy. So now you can tell whether a quadratic is positive and negative definite just by doing this calculation. Writing down the value of A, writing down the value of the discriminant. Do that now. Right, looks like most people finished. We're going to go through it soon. Wait for the answers. Where are you going? Okay, I'm going to ask Christina, what's A equal to? What's discriminant equal to? Okay, very nice, good. So the graph is concave. Down, very good. And how many roots? Less than 0, so no roots, 0 roots. So we see it's concave down, doesn't cross the x-axis. What can we conclude? This is a negative definite. Very good. Right, all done. So that's one type of question you could get in the test. Let's look at the next one. This can get a bit harder. Okay, so it's saying, show that this inequality is always true for all x. when the question say that, it's actually saying show it is positive definite. So if it's always positive, it means it's positive definite. And the question is, how do we show that? Well, we just did that above, isn't it? We have to look at two things. Which two things do we look at? The A value, which is 3, which fits the first criteria, give a tick. Next test, discriminant should be negative. Let's see whether it is negative. Minus 4AC. Do the calculation. Sort of you can tell it's going to be negative, but it's better to work out what the value is. That will be 60, so it will be 50, negative 56. So it's negative. So when it is concave up and discriminant is negative, we say, therefore, the quadratic, or you can just say it is going to be positive for all x. So whenever it's positive for all x, it means it's positive definite. That's what that means. All right, does that make sense? So when the question says show something's always positive, it means it's trying to show it's positive definite. Does that make sense? And the next one's very similar. Show that it's always negative, so show it is negative definite. So you have to check two things, and then the question will be answered. Okay, so show it's always negative means show it's negative definite. So how do we show that? Write down A value, write down discriminant, and then your conclusion. All right, very good. And then we'll do some harder question after this. Okay, let's go through this. So we got this value. So Nat, what's the value of A? Yep, and discriminant. All right, let's see. -1 times -1. That will be 1 minus 4, -3. Okay, so what can conclude, therefore, it is negative definite. It is negative definite. And therefore, we can conclude, therefore, we say the quadratic, it's always negative for all x. Emphasize all x. Okay, that's what negative definite means, that any value of x you substitute into the quadratic, you always get a negative value. Okay. All right, hopefully you're all done, and then we're going to move on to the next page where we'll do some harder questions, which you will get in the exam. All right, let's move on. 1, 2, 3. Okay, good. Okay, next question. All right, the questions say the following. You say, now we have to find k. We've been doing this question before, right? Where you have to find missing coefficient. You have to find a k so that it's positive definite. So when you see the word positive definite, you think about two things. Which two things you think about? The value of A and discriminant, right? So A has to be positive. So is A positive? Yes, it is. It's already fit the first criteria. What's the second criteria? Discriminant has to be negative. Yeah. Okay, so let's find the discriminant. It is b squared minus 4ac. And that has to be negative. And you solve for k. This is a linear inequality. Graphs are not required. You can just work out like this and just solve it directly. Okay, do not need to draw the parabola. So let's move on. So what do you do next? Move the 36 to the other side, so you get negative 12k less than negative 36. And when you divide by negative 12, you must switch the inequality sign, which is 3. So we note that if k is more than 3, it's always going to be positive definite. Does that make sense? So find a k so that it becomes positive definite. K has to be more than 3. Does that make sense? All good? So when k is more than 3, you'll be positive definite because you will fit the both criteria. Right, we've got one more question to go, then we're done. All right, next one. Hopefully you're ready. Next question, same question. What values of A so that it is positive definite or negative definite or indefinite? Let's answer the first part, part 1. If it's positive definite, you need to be two things. A has to be positive, discriminant negative, right? Okay, let's A. So for this one, A is already A, right? A has to be positive, and the discriminant, which is equal to B squared minus 4AC, has to be negative. And let's simplify that. That will be 64 minus 4A squared. Now, unlike the previous question, we have to draw a parabola because it is a quadratic inequality, whereas the one before, you don't have to do that. So we have to draw this graph. Now, how do I draw this graph? You do that, you first solve the equation first, equal to 0, and then you write 64 equal to 4A squared. Divide by 4 is A squared equal to 16. Then square root, you get plus or minus 4. So a little, quite a lot of steps involved. So after you do that, you're going to draw it. Okay, so how do you draw? Is it going to be concave up or down? Concave down because the number in front of A squared is negative, crossing the x-axis at 4 and negative 4, right? So you concave down, parabola. Remember, we're drawing A against the discriminant. And we want the discriminant to be negative. And when is it negative? Over here, over here. So A will be less than negative 4, or A will be more than 4. Get the idea? Well, excellent. Good point. So once you do that, we must check that both conditions has to be fulfilled. So A has to be positive, so we have to eliminate the negative. So A bigger than 4 only, which makes it a little bit tricky. Yep. So you have to check both. So if they see the one before, there's no problem, right? A is really 3, right? It doesn't affect the K. But in here, they are linked, right? A bigger than 0. This condition cannot contradict with this one, right? So if that's negative, that has to match with the first condition. Yep. All right, next one. Next one will be much easier because we got most of the work prepared. Okay. All right, part 2, negative definite. Negative definite will be A will be now negative, discriminant still negative. But we got discriminant negative already, right? We've already found that from part 2, part 1, that discriminant negative means A less than negative 4 or A less than more than 4. That's right here. A less than negative 4 or A more than 4. So, because A has to be less than 0, therefore we have to eliminate the positive one. So we say for it to be negative definite, we say A has to be less than negative 4. Yep. All right, cool. And then we're almost done. Last part. Indefinite. Well, indefinite is actually easy because you don't have to look at A. For it to be indefinite, discriminant just has to be positive or equal to 0. A doesn't get involved, so discriminant has to be positive, so which part? It's got to be here, right? So you say A has to be between negative 4 and 4. Any question? But there's a tricky part here. We need to remember that for a quadratic, A cannot be 0. Right? Because it's a quadratic. Because A is number in front of x squared, A cannot be 0. Otherwise, you will not be a quadratic. Right, all done. So let me draw boxes around this so that you won't get confused. So that's part 1. That's part 2. And then that's part 3. All right, so you will start the worksheet today. I will give you a worksheet to do today. So, and then you can start the work. You can do the worksheet in your exercise book.